I am Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. In this video, we will learn how do we find equation of the tangent graph given to us. The question is, write tangent function of the form y equals to a tan kx plus q for the following graph. Here is a graph given to you with 3 critical points and the vertical asymptotes. You can now pause the video, answer the question, and then look into my suggestions. From the equation, it is absolutely clear there is no horizontal translation. There could be horizontal and vertical stretches or compressions and vertical translation. From the points, we do see that these points have moved from their original position. Now, when I say original position, what do I mean? So let's review the graph of tan x. So here is a quick sketch of the graph of tan x. It is always increasing with vertical asymptotes at, let us say, minus pi by 2 and pi by 2. So the graph is actually kind of like this. The critical points which we are talking about are these points. Vertical asymptotes at minus pi by 2 and plus pi by 2, 0 at 0, and then we have the value of plus 1 at pi by 4 and minus 1 at minus pi by 4. So what you see here is one cycle. So the time period is t, which in this case for the parent function is pi by 2 minus pi by 2, or you can say pi. Now these critical points are having the y value of 1 and are at quarter of the cycle. You get the idea. So pi is the time period, and at quarter of the cycle we have plus and minus values for this always increasing graph as shown here. Now there is a vertical translation. In that case, the point in the center will move up. And we can see that the point in the center has moved up in the given graph, and clearly there is a vertical translation of 1 unit. Now if we apply a vertical stretch on this particular graph, 0 gets multiplied with any number giving us 0. However, if 1 gets multiplied by any number, it gives you the stretch factor. So what we notice here is that a is equal to the difference in the center value and that value. So we can actually name these points, right? So let me name them as point A, B, and C. So accordingly, we will have the points as A dash, B dash, and C dash on the transformed graph. So what you notice here is that the value of A is actually the distance between A dash and B dash. Because if A is, let us say, 2, then this value 1 will become 2. But the value at B will remain 0. So that difference is the vertical stretch for us. So we can say that the y values between A dash and B dash will give us the value of A. right? So that is vertical distance. It is vertical stretch, right? A dash minus B dash. As far as the time period is concerned, time period is basically the time between the two vertical asymptotes, right? So T is equal to, we can say, vertical asymptote difference. So we get the time period, and from time period we can find the value of k as 2 pi by t. So I hope that concept is clear. And the q value, as we discussed earlier, is actually vertical shift for b, which we say b dash. So that is the q value. Is that clear to you? Now with this concept, one more thing which you see is the graph given to us is decreasing. Decreasing means what? Can you tell me that? Decreasing means that a is less than 0. It is negative, so the graph is reflected. So I hope now the concepts are clear. Putting all these concepts together, we can find the equation of the given tangent graph. Correct? So you saw our approach. Our approach is to really understand each and every point. So we are saying this as a dash, this is as b dash, and that is as c dash. We want to find an equation of the form y equals to a tan kx plus q. So we'll begin with how far away is b vertically. So q is vertical translation. So that distance refers to q. So from here we can clearly see it is 1 unit. So we can say that q equals to 1. Now the value of a, as we discussed, is vertical distance from b dash to a dash. In that case, the vertical distance is 3 minus 1, which gives us a value of 2. However, we also notice that the graph is decreasing. I should write absolute value of a is 2. Since it is decreasing, a is less than 0, and therefore we have the value of a as equal to minus 2. Is that clear to you? So easy, right? Now let's find the time period. For the time period t, we need to check the distance between the vertical asymptotes. So we see the value is 6 and 2. So t is 6 minus 2, which is 4 in this particular case. Since t is 4, we can clearly write the value of k as pi by 4. So you see how easily we get all the parameters written here. So now we are in a position to write down the equation. Perfect. You can pause the video and write down your answer. Here is what we observed. So from this equation, once again, we first looked into the key points a dash, b dash, and c dash. Now the point b dash is actually the average value of a and c also, if you look at it. But on the other hand, since we have this graph, we can read it directly. The value of b dash has gone up by 1 unit. So that is what is q. And so we get the value of q equals to 1. As far as the value of a is concerned, a is the distance between, vertical distance between a dash and b dash. And so we get the value of a as equal to the vertical distance 3 minus 1, right? So 3 minus 1 gives us 2. This is the absolute value of A. Since the graph is decreasing, once again I'm writing the parameters. A will be less than 0. That means the value of A is actually equal to minus 2. For the value of K, we figure out the time period, which is, we have to look at the vertical asymptotes. Now, in this case, the vertical asymptotes, one is at 2, the other one is at 6. So, the difference between them is the time period. So, this delta value is basically 6 minus 2, which is 4. And that gives us the value of K as pi, the regular period, divided by 4. So, now we get the equation as y equals 2 minus 2 tan of the K value pi by 4 x plus the Q value 1. Is that clear to you? So that is how very easily we can actually find the equation of the tangent graph without doing much calculations. So remember, tangent graph is always increasing. If we are given a graph which is decreasing, that means the A value must be negative. The center point of the three critical normally would be at 0, 0. Now with vertical translation, it moves up or down, and that gives you the value for Q. The vertical stretch factor can be calculated by finding the difference of y values between A and B dash, as given in this particular solution. So with that in mind, I hope it is absolutely clear. How do we find equation of a tangent graph? If you like to learn from me, you can always send an email on the address given. We can have one-on-one online sessions that will help you to understand the concepts and apply them in any application. Feel free to write your comments and share your views. Visit our website for more information. Thanks for your time and all the best.